Good afternoon and welcome to the Columbus Metropolitan Club. We're live streaming from the Boathouse at Confluence Park, and we're very, very happy to have you here. My name's Jane Scott. I'm the president and CEO of the Metropolitan Club. And you know, it's really terrible. We really miss having an audience here in the room with us. So we're equally and more grateful to have you watching online. So thank you very much. The Metropolitan Club is live streaming is presented by the Emergency Response Fund of the Columbus Foundation in partnership with the Columbus Dispatch and PNC. We're very grateful for this support. We'd also like to thank our sponsors and those of you who are watching today who purchased a virtual seat for the forum. We appreciate your support, and we're able to continue the live stream a large part because of this support. So thank you again very much. The robot revolution is not just science fiction, it's here. Machines now perform all sorts of tasks. They clean floors, stores, open doors, patrol borders, and help children with autism. What roles will robots play in our economy, and what does the future hold for business, for opportunities, and for the workforce needed to power it all? So let's talk to our experts and find out. President and CEO and Chief Goddess of the PATH Foundation, Annalies Corbin. CEO of PATH Robotics Incorporated, Andy Lonsberry. And CEO and founder of Ready Robotics, Ben Gibbs. And our host, the founder of Drive Capital, race car driver and former director of the Department of Development for Ohio, Mark Kvamme. Mark, it's all yours.
Thank you for that virtual rapturous applause. I really appreciate that. I could hear you all the way here at the Boathouse. Well, this is going to be a fun panel. I'm really looking forward to it. We have three real professionals here in our three panelists in this whole area. But what I'd like to do first, maybe starting at the far end with Andy, just give a little bit of a brief background of the company. We're going to keep it very short and what you're doing. And then I would say secondarily, when did you realize you were interested in robotics? What was the epiphany moment for you? And I'd like each one of you to take it from there. So Andy, let's go.
Okay, thanks, Mark. So PATH Robotics is an AI robotics company. And the AI part means that we focus on computer vision and machine learning to have robots learn how to do tasks. And the first task that we're having machines learn how to do is welding. So we deploy into the industrial manufacturing sector, specifically around welding and finish welding and tack welding. And when I had that aha moment, it was probably when I was getting my undergrad degree in mechanical engineering. And I saw for the first time a Boston Dynamics robot dog walking. And that's when I knew I wanted to go straight into robotics at that point. I wanted to create systems that could replicate humans, that could replicate animals and biological organisms, and be able to start to do things that we could do.
Great, thank you. Annalies.
Yep.
Thank you for having me today. I'm Annalies Corbin, President and CEO of the PATH Foundation. PATH Foundation is a nonprofit 501c3 STEM education organization that's been around for about 20 years. And we spend a tremendous amount of time thinking about STEM access and opportunity and workforce development, and those intersections between what could be a potential career, and more importantly for us, the passion to be part of that career. We see that to be a real game changer in terms of the work that we can do in the world. And so through that, we have a variety of different robotics programs that we've been engaged with for 10 years or more. Everything from underwater robots and ROVs to drones of every description you can imagine. And we also partner with FIRST Robotics and do a lot with robotics programming in that sort of K-12 and post-secondary space. And for me, the aha moment in all of the robotics work is when I see kids that have just been bored with school, or you couldn't get them to engage, or they wouldn't show up, who the minute you toss out with the little ones, you know, Legos robotics or Mindstorm kits, or the older kids, our high school and collegiate students who are competing in robotics global challenges, and I have to literally send them home at 1 in the morning. You need to leave now. For me, that's the reason we should be involved in this space.
Great, thank you. Ben.
I'm Ben. I'm the co-founder and CEO of Ready Robotics, and what we do at Ready is make a piece of software called Forge OS, which is the equivalent of the Windows operating system, but for robot arms. Today, every robot arm actually has its own esoteric programming language that is overly complex, and so we've simplified all of that with a series of intuitive interfaces that enable anyone to be able to program any robot for any task. So we've demonstrated an ability to teach not only K through 12 on how to do this type of stuff, but also upskill people like former coal miners in eastern Kentucky who went from knowing nothing about robotics to being able to program robots for lights out operations in a 2-week period, which is critically important because there is a massive skills gap in the manufacturing industry today with over 500,000 unfilled jobs. For me, the aha moment for robotics, where I really got bitten by that interest, was when I was doing technology commercialization at Johns Hopkins University and got exposed to first surgical robotics. Seeing a Da Vinci system up close was an amazing experience, and getting to meet one of the professors who, in his previous life at IBM, helped create that system and hear firsthand from all of these amazing inventors the possibilities for how robotics and automation can make life better for everyone.
Great. Well, obviously this is a subject area that people are talking about a lot. And whenever they talk about it, they talk about the replacement of human workforce. And it's a subject I've heard for many, many years. My father was a founder of National Semiconductor, and then after that, they built a mainframe system. And I remember I was with him with some friends in a parking lot, and one of the men asked, well, what are my kids going to do? Aren't you going to replace all of my kids as workers, and we're not going to have work? This is about mainframe robots. So we've had this discussion for a long time. So I'd like to ask the question maybe in 2 parts. The first part is, if you, I don't know if any of you guys have kids, but if you had young kids, what would you tell them to do in this new environment? Where would you go explore? And then secondarily, maybe from Ben and from Andy, what are you looking for in people? What kind of skill sets are you looking for to hire and to bring them into companies like yours? And then the third part of it is, I'd love a quick part of your opinion on, is this going to replace jobs, enhance jobs, make the human condition better, make it worse? I'd love your kind of thoughts on that. Maybe we start with you, Ben.
Yeah, so I do have a young daughter, and I very much so intend to make sure that she knows how to program, because being able to program computers is going to be critically important, and programming is also how you control robot systems as well. So being able to program is truly going to enable you to participate in a meaningful way in the economy that is being created with robotic systems. Now, I would also say that in general, robots do not destroy or take away jobs. In fact, there was an interesting study that came out a little over a year ago looking at companies in Spain, and they found that manufacturers that deployed robots actually ended up hiring more people because they were more competitive, they could bid on more jobs, they could make more money. Those that said, we don't want to deploy robots, ended up having to lay people off because they weren't able to keep up both from a productivity standpoint and from a just cost standpoint. So what I've seen firsthand is that anyone that works in the manufacturing space is not worried about robots replacing jobs. They're worried about just getting enough people as it is to be able to keep up with all of the work and demand that really has only gotten worse with this entire pandemic. And I would say from a hiring standpoint, the type of people that we always look for are people that certainly can program. That is very important. But the number one attribute that I'm always seeking is an innate curiosity, where they just look at the world and they always want to know why. They always want to dig deeper and figure out how they can solve all sorts of interesting and challenging problems.
Great, thank you. Annalies?
So I want to echo everything that Ben said because it's spot on. And I have 3 children, two grown children, and my youngest is 16. He's a junior in high school in a robotics and engineering program. And the thing that was just adamant for us as we were thinking about as a family in terms of sort of where or how do you want to grow the appropriate sets of skills and curiosity in the young. I tell everybody, go out and explore the world as much as you possibly can. And that can be everything from walking through the woods to playing games. Spend as much time as you can playing games, really complex games, from board games or creativity, make-believe games, all the way through online, really, really complex games. Because, so much of this that we see when the students start to get to the point where they're now participating in robotics programs, whether they're interested in robotics or engineering at all, and quite frankly, we don't really care, because we want as many people in our world to have and appreciate those sets of skills, to be able to think on their feet, to work as a team, to understand how the different systems come to play with each other. That's absolutely critically important. And I do appreciate and echo the notion about programming and coding and just really, really helping students think about those collective sets of skills. And we hear the same argument as folks come and tour inside at the PASS Foundation at the Innovation Lab all the time to see the programs that are happening. And I will hear people comment sort of in the crowd as we walk through, and especially when we get to the back of the building where we have, a permanent installation of an FRC robotics competition arena in the building all the time, 24/7, year-round, by design. And it's there because we want to be able to take any content, any workforce program. It can be healthcare, it can be engineering, manufacturing, take your pick. We want to be able to show the intersection between technology and whatever that industry happens to be. And the best way to do that is to get kids engaged in solving a problem. And it could be a giant global problem, or it can be that very localized one inside the competition. But I hear people talk about all the time, oh my gosh, these kids are going to build the robots and I'm not going to have a job, or so-and-so's not going to have a job. And quite frankly, that's BS. The flip side of the robots are the people who are designing, developing, deploying, thinking about them, and coming to the next set of iterations. So that's critically important. And we also get asked the same question about what are the skill sets for the jobs folks that Andy and Ben are going to be ultimately hiring. And I hear the same thing. I need problem solvers. I need people who are fearless. I want them to be critical thinkers. And I want them to believe that they can actually solve the world's problems.
Thank you. Andy?
Yeah, so I don't have any kids, but I do have a very young new niece in the family. And she actually just took my title of youngest in the family, so it's a little bit of like a bittersweet situation of having her. But I used to like all the attention of being the youngest. And so she's 5 months, so super, super young. And things that I'm going to be helping with my family into coaching her is obviously into programming, similar to what you guys were talking about. But just to maybe stray a little bit to a different course, I think we're also going to be pushing heavily on being super creative. So jumping back into the arts. And having culture be a big part of it. And so one of the things that we look for specifically at Path and hiring is not only having a great math and science background, that goes without saying, but we really look for people that have also an extreme creative background. So people that have been artists in the past, people that are musicians, people that are expanding their own horizon through creativity is really, really important to us. So one of the best engineers I know, he's a principal researcher at the Stanford Research Institute. He did his undergrad just in art, and then he went straight to his Ph.D. in robotics. But since then, and because of his creative background, he's been able to make complex, really, really, truly amazing engineering products and projects. And it's really, really opened my eyes to the fact that, not only do we want great problem solvers, great critical thinkers, but we really want people that are pushing creativity. So that's kind of like a big thing for us. And then on the side of, do I think this is going to make humanity better? No, I think Terminator's coming for everybody. No, just kidding. We think obviously robotics are going to be a huge part of the future for humanity, and it's only going to continue to increase and make humanity just overall just better. And we've seen it from healthcare all the way to industrial manufacturing. At Path, we don't see ourselves replacing anybody, we're filling voids. So we focus on welding, and the American Welding Institute estimates by 2024 there'll be 400,000 human welder vacancies in the United States alone. This is a huge labor gap, and that huge labor gap has massive impacts on our infrastructure then, and the production of materials and parts and anything that really goes into the U.S. economy. that's a huge gap to just be missing. And we plan on helping to fill that gap as much as possible. And we also see that outside of welding, but also in assembly and painting and all other trades that are currently being done. And we're looking more to amplify, manufacturing and amplifying the human race by creating these systems that can do things for us.
I think that's an excellent point, Doc, about how automation can really raise the bar for everyone and really just improve humanity in general. 'Cause if you look at global manufacturing, there are about 400 million people globally involved in manufacturing, and that's enough to just make enough stuff for less than 1% of the world to live the way that we do. Imagine if we wanted to make 10 times as much stuff, so just 10% of the world lives the way that we do. You would need 4 billion people involved in manufacturing doing it the way that we do it today. The only way that we're going to be able to effectively get there is through robotics and through automation, and I think that that is ultimately a noble thing, that we can help improve quality of life across the world for everyone using robotics.
So this is a question for Andy and Ben. Everyone, we watch The Terminator, we watch these movies, and these robots are amazing. They do everything, and so on and so forth. You guys have just created 2 robot systems. Primarily you're in lathe operating and things like that. You're obviously a welder. I'd be curious, what is the simple thing that humans do that was the hardest for you to get over in your technology? Why don't we start with Andy?
Oh, wow. There are a lot of things. So humans are credible. So we focus on computer vision and tactile feedback. And these are things that we take for granted as being humans. Your ability to interact with the world and take that feedback and make decisions on the fly is not a simple thing to have a robot be able to replicate. And obviously there's been a lot of changes in learning algorithms and what over the past decade, and really it's been over the past 5 years has really been the massive acceleration in AI. But making that hurdle of allowing robots to make a unique decision on their own, an environment that they've never seen before, is our biggest hurdle. That's one of the hurdles that we at Path specifically focus on. And it's, again, something that humans do constantly without even knowing, all day, every day. So that's the task at which we're trying to actually solve.
What about you, Ben?
Yeah, I think that hit the nail on the head. I mean, it's your eyes and it's your hands, that tactile feedback that gives humans such a leg up over, frankly, what are dumb robot systems. And one of my eye-opening moments was when we were actually looking at a CNC lathe and we were talking to the operator about how he did it. And from my untrained observation, it was just, okay, he takes a piece of metal, he puts it in the machine, closes the door, and hits the button, and just does that over and over again. And then watching that cycle occur about a dozen times, I noticed that he was actually jiggling the part a little bit as he put it in there. I said, why are you doing that? He said, well, I'm checking to see how much the chuck, which is the part that holds the metal, is wearing down, because that wears down over time. And I know that if it jiggles too much, that it's worn too much and we have to replace that chuck. Well, the robot's not going to know how to do that, right? And how do you get the robot to sense that? And so it was, you have to add in a force sensor, and you have to integrate these other capabilities, and then you have to make sure that you trained that robot to account for that. So we had to program that operation in with the force sensor, where it was checking how much the part wiggled, and if it wiggled too much, you sent an email to an operator to come by and check on it. And so I think Andy's absolutely right, where it's those type of decision-making situations that we take for granted, and frankly, we don't even think about, because we just do it naturally, that is the next gap for robotics to really overcome. And that's something I think that, you look at a company like Bossa Nova Robotics, where they just recently lost a major contract with Walmart, because Walmart found that the humans could still do the aisle and inventory checking better than the robot could, because 95% of the cases, no problem, the robot could do it. But sometimes the Tylenol bottle was behind something else and you can only see a part of it. Well, the human eye sees that and says, oh, I recognize that red, that's that Tylenol red, and I see a little bit of the T, and that's a Tylenol bottle. Robot has no context for that. And so it's that type of training that really needs to occur for this next leap in intelligent robotics to truly take off.
Thank you. So Annalies, I look at you as kind of like a Super Bowl team owner. You put together teams and you go on robot challenges. I have two questions. One is, give the audience a little bit of a flavor for you've won some of the world championships or some very cool things, been to the World Robot Challenge. What do you look for in a team? What do you look for in putting together these problem-solving kids? Because they're, what, 16, 18-year-old or?
Yes, so the kids that participate in the robotics programs we start with them in elementary school. So we start with them when they're, quite frankly, really, really young. And by the time the kids get into sort of the high school and the collegiate level robotics competition works, whether we're talking about the underwater robots that we utilize through a program called MATE, which is ROV, remotely operated vehicles. And, you know, we've got teams that have participate from all over the world in a variety of different challenges that are very, very real world in the sense, if you think about the fact that locally, you know, we have an astronaut, Kathy Sullivan, one of our local heroes, if you will, in our community, who just recently went to the deepest part of the ocean, right? But she's also been in space. And so if you think about that skill set that was required to be able to participate in both ends of that spectrum, right? Those are some of the things that we're trying to get at. And so, you know, if you want to be able to project a path that makes it possible for you to be able to do that, part of what you have to learn really, really early on is, you know, what does it mean to be on a team? And then we step back and think about, and then how do we formulate that in the sense of what kind of questions do we really want to make sure that students are very, very comfortable in? And, you know, the students who participate in the FRC robotics, we have a number of different teams that we support at the Innovation Lab through those high school robotics programs. We have 5 teams that live in-house in the facility with us. And several of those teams have been and participated in World Championships numerous times. We have our in-house residence team, our Metrobots. A big shout out for those kiddos. They're awesome. And I tell folks that come that I would put them up against any R&D team in the world. From any industry. And the reason I say that is because they have scaffolded their skill set and their understanding. But more importantly, one of the things that we do with them, and I think this gets to the essence of how do you build the teams, right, is that the team aspect and opportunity there is to recognize that not everybody can, should, and will have the same skill set, and that we need to honor the variety of those skill sets. The greater diversity of our team, the greater diversity of the potential solutions that we are going to have. And we see that. And one of the other questions that we ask the students repeatedly, even if we don't ask it to them directly, it's always sort of in the background of what's happening at the Innovation Lab, and whether it's the robotics programs or any of the other STEM programs, it's the same. It's what is the science or that opportunity, if you will, to impact back towards humanity, to come back to something that Ben was talking about. And because that is that sort of fine interface, I guess, if you will. You know, the humanity piece we can replicate through the tool set, the robot, the ROV, the drone, take your pick, that on the manufacturing floor. We can do those things. But at some point, we have to recognize that the decision-making process is beyond the algorithm tied to what it is that we're trying to accomplish. And that's that humanity piece that's really, really hard. You know, especially the students who want to focus exclusively sort of in the math and science space. So I appreciate that Andy's talking about the creativity and the arts component, because we see that as critical as well. Those teams have to have all of those folks, because somebody has to stand there and say, yes, but should we? Not just can we.
So we are the Columbus Metropolitan Club. You all 3 are based in Columbus. What do you think the advantages of building a robotics company in Columbus, Ohio, versus other places? I mean, you moved from the East Coast, and you moved from, you're still in Ohio, but from Cleveland. So I make it Ohio question. I don't want you, offend any Cleveland Brown fans. But why do you think it's unique? Because you normally would think this is at, Carnegie Mellon. You'd think this is at MIT. You would think this is at Stanford. So what makes this place unique, Ben?
So for us, it was easy access to customers, right? So 60% of the factories in the US are here in the Midwest region. And if you look at who buys robots, it's these factories primarily here in the Midwest. That's why all of the robot arm manufacturers themselves, their North American headquarters are in either Michigan or Ohio, because these are the places with the most innovative factories that are buying the most robots. And you couple that with access to technical talent coming out of places like OSU, but also just more seasoned programmers who have been working with software, but software that operates on real pieces of machinery, right, at places like Honda or L3, that it's critical for us to have programmers that understand that the stuff that they produce is going to operate in the real world, right? Like, we don't want to move fast and break things because we might hurt somebody, right? We want to move at a deliberate pace and make sure that we are understanding that that impact has, real world consequences there. And so that combination of customers and talent is what just made it a no-brainer for us to move here.
So why do you have so many world-class teams, Annalies, coming from Columbus, winning world championships?
Because Columbus is a wicked cool place, for starters, right? But I think it ties directly back to what Ben is saying. One of the things that I love about Columbus, because I get asked that question all the time, why is this happening in Columbus? Why are all these robotics teams? We have, I think, 96 teams just within the tightest circle just right here, in terms of both the underwater, the drones, and the traditional robotics. And so it's across the board. And I think that one of the reasons that happens in Columbus is look at what goes on here, right? We've got startup, we've got hackathons, we've got, this amazing culture of innovation in this city. And I would argue that Columbus is fearless when it comes to, I don't know how, but what the heck, let's give it a try.
Great. Andy?
So Ben and I have very similar answers. So we were here mainly, at first, was because of the customers. Obviously, a lot of people are buying robots in the Midwest, so there's a lot of companies that are doing industrial manufacturing. But then even at an even greater level, there's about $6 billion worth of welding that's done in Ohio every year. And for us, that was a big pull. We wanted to stay here. We wanted to stay really close to our market and our end user, and we wanted to be able to give them that attention that we knew they would need, especially on early deployments into advanced technology and whatnot. I think the big surprise that we had was just how good the technical talent was. Not gonna lie, at the beginning we were like, okay, Silicon Valley is known as the technical hub, especially for AI, machine learning, computer vision. But it just ended up being a total 180 for us. We stayed in Columbus. We recruit out of OSU. We recruit out of Michigan. We recruit out of Illinois, Virginia Tech, Georgia Tech. And the schools have just been absolutely, absolutely amazing. The talent is amazing. We feel that it actually brings a really unique diversity to our team when, maybe this guy has a Ph.D. in computer vision, but his dad or his grandfather worked at the steel mill in Cleveland. They're really, really grounded and rooted to like the mission at which we're doing, because so many people that have lived and are living in Ohio and in Columbus specifically, you're only like one step away from a relative or a family member that was in manufacturing, that worked at a steel mill, that was a welder. I mean, Mark's a welder, and so it's just been really great for our company specifically to be here.
Well, that was a good lead on to my next question. So as you said, I'm a welder, and when I saw your technology before we made the investment, I thought to myself, I wish I could weld that well. It was amazing, perfect welds every time. And I guess it's a two-part question for you and Ben. You now have many installations in the field in manufacturing places. And in some cases, they're replacing people. In some cases, they're enhancing people. How's the reaction of the welders, of the lathe operators? Is there kind of I don't like it, this is crazy, and then, oh man, this is good, and what's the range of emotion that they follow over a period of time? And I'll start with you, Andy.
All right, so first time we ever delivered a robot, it was a disaster. So the welders' emotion at the beginning was that they just loved to make fun of the robot. And so they really got a kick out of seeing this thing fail day in, day out, day in, day out. But as it started to get better and better, then there became that, it went from laughing at it to then being actually a little bit concerned about it, because then you start to see, whoa, this thing is kind of learning, and could it take my job? And that became a little bit of a concern. And then as it got better and to the point where it was doing a really good job, they actually flipped to the other side, because it was taking the work that was really long, tedious, and wasn't what they wanted to do. So as human welders that we were working with on one of our first deployments, they were very good at assembling, so grabbing multiple objects, putting it together. And the part that was the worst part for them was just sitting there holding the welding gun hours at the end, bending their back over, getting into it, getting really hot, breathing in the fumes. And we ended up taking that portion of it, which allowed them to go back to the pieces that they loved, allowed them to be more complex in their problem solving and more diverse in what they were doing on a day-to-day basis. And so it ended up being pretty good at the end, I would say. But it had a full range of emotion, from laughter to fear to excitement.
What about you, Ben?
Yeah, we've seen situations like that as well. For me, one of the most indicative anecdotes here was when we went to deploy a system, and it was on a set of lathes, and we started installing it, and the operator for that lathe then shows up, and management, for whatever the reason, had neglected to tell him that a robot was being installed there. So he literally shows up and looks at what's going on and goes, "Is this your way of telling me I'm fired?" And we said, no, hold on. No, we're installing this robot. It's going to make your job easier. You're going to actually be the guy that manages the robot and programs it. And he said, no way. Robots are too complicated. I can't tackle that type of stuff. And that really speaks to the importance of making this type of technology accessible in a meaningful way, because by the end of the day, with some very basic training, he went from thinking he was going to lose his job to walking around with his head held high saying, I'm a robot programmer, right? And he's actually been one of our most successful programmers. He's taken that system and he's reprogrammed it over 150 times for a wide variety of SKUs, saved the company millions of dollars, and really created in himself like a better sense of self-worth and what he could accomplish, because we took something that was unnecessarily complex and made it easy and accessible for him in a way that he could then apply his domain expertise in a meaningful way.
Yeah, I can actually attest to how easy your robots are, and the fact that Nick and I taught your robot to pour us a beer. And
VC can do it.
Yeah, anybody, even venture capitalists can do it. So we're going to have questions here in a little bit, but I thought before then, I'd love to, you guys are futurists, you guys are in the field, you're seeing it on a day-to-day basis. Let's imagine now it's 2030. What are we going to see that won't surprise you? So what is something that you believe is absolutely going to happen? I'll give you, maybe help this with an analogy. I remember when I first met John Kasich, why I'm in Ohio, in 1997, so this is 10 years before the iPhone, he asked me, what's the future? And I said, the future is the constantly connected consumer. We'll have access to all knowledge, all products, everything in real time. And luckily, I got it right. So, Ben, what 10 years, something you think is going to happen?
Robots will be so cheap that we're going to start to see them everywhere. The MSRP for a robot today is a little under $40,000, but there's robots coming out today that are in the $7,000 to $10,000 range, and I think by 2030 we're going to see robots that cost $4,000 to $5,000, and at that point there's going to be this massive explosion of innovation where, just like with PCs that started off with very narrow use cases, they proliferated from the businesses to the homes and all sorts of applications that 30 years ago you wouldn't have even imagined. And we're going to see that same thing play out with robots.
Great. Annalies?
So I think that, by 2030, when I step back and sort of think about who is that going to represent, so that's our kids who are in school right now, and the quality that these kids have that we have not seen in generations previous, and that's always the case, right, as generations change. But this group in particular, I'm really excited about, because they are rapid prototypers by experience. And what I mean by that is it's a generation that has spent their entire lives not only connected, right? So they're going to be robots everywhere doing all these different kinds of things, and they're going to be absolutely fearless in that environment. And they're not going to think twice about them or those things in their environment, because their entire lives have been basically, one after another new version of something coming out, right? And they don't even have to wait for the thing to run its course because it's okay. That constant state of iteration is a mindset that we have never even had access to before. And so what I think we will see, sky's the limit.
Great. Andy?
Yeah, I mean, I think the next 10 years is going to be just phenomenal. Kanye West will probably be our president at that point, and so I think we'll see that. But on a more serious note, I think we'll probably see a big increase that will affect everybody is robotics in healthcare, and I think that's going to be a huge next step that we're going to take, and being able to actually be able to synthetically replicate different components of the body and whatnot, and I think we'll start to see this increase.
The $6 million man is happening?
Maybe not quite in 10 years, but I think in my lifetime, we're going to start to get closer and closer to that. I think synthetic materials are just making just great progress, and the ability to actually start to replicate more of the human organs, I think will definitely happen. We'll see something similar to that in 10 years.
Great, thank you. So everyone out there in the audience, we will be taking live questions, but we also have some questions that have come over the transom prior to the conference. So we're going to go and ask some questions from the audience.
Well, some of these you've discussed in some detail already, but Ian Lytle from Summit Funding Group, robotics related specifically to the supply chain, logistics, packaging, palletization. He wants you to talk about that a little bit.
I think, Ben, that's a good one for you, right?
Sure, happy to answer that. Yeah, so there's definitely a big proliferation in palletizing for robots. That's always been a big use case, but it's expanding pretty rapidly. But to me, the interesting aspect of that is the marriage of those type of robots to things like AMRs, autonomous mobile robots, which are basically these platform type robots that you can stack things on top of, and then AGVs as well, and sort of some larger autonomous systems like forklifts. So there are companies out there now that are either making autonomous forklifts from scratch.
A Drive portfolio company, Vecna.
or retrofitting existing ones, right? And that's a huge use case, right? Where you can start to automate a large portion of the supply chain and also take a lot of danger out of it as well, right? Like forklift injuries are one of the leading causes of injury and death in fulfillment centers because they're big, they're carrying heavy loads, and they move really fast. And being able to automate that, take the human away from that dangerous environment is going to be very transformational when you couple it with all of these other automation technologies.
Great.
So Rich Granger from Drive, Ohio. What are the top skills that today's workforce and our emerging workforce will need to succeed in a workplace filled with more robots? In other words, what skills are we going to need to work with the robots?
That's a great question for Andy.
Yeah, so skills that we see every day are people that have computer science backgrounds, so the ability to program is definitely one of the biggest. A really, really strong math background is also really important for us. So people that have taken calculus or whatnot, that's really important for us to be able to do all sorts of type of mathematical planning, trajectory planning for robots. We see those being really important. The question was 6 skills?
What key skills?
Key skills. Yeah. Okay. I was going to say, how do I get to 6? Math obviously is huge. Programming is huge. Creative problem solving is really large and really important as well. Yeah, I'd say those are the kind of the key ones.
One thing Annalies mentioned was playing games. I always tell parents, if you really want your kids to know what's going on in the future, play Minecraft. Have your kids play Minecraft, for example. Are there any other, maybe Annalies, are there any other examples like that?
We advocate for the students to build games. So, and I mean, electronic or digital games, absolutely, and we scaffold kids to that, but literally build board games, build strategy, build something that requires that you think about all the possibilities, right, that gets directly into the industries that you represent in that sense. And so, yeah, we every time we offer a Minecraft program, and we offer them all the time, we sell them out usually within a few hours of the seats opening, and it's from little tiny kids all the way to older kids, sort of take your pick, so absolutely.
Great. Next question.
Bill Lafayette, are you getting all the funding and the workforce that you need? What one thing would you do to enhance the environment?
Do you guys want more money? What are you guys missing? Maybe for Ben and for Andy, what are you missing?
So I would say something that's missing from the broader workforce is just a healthy understanding for the different ways that you can use robots. I mean, we see that a lot where someone gets their first robot into a facility and they start to do some different stuff, and then there's like a light bulb moment where they're like, oh, I can do this and that and this other thing with it. And there's not enough people out there that understand the possibilities of how you can apply robots in a wide variety of ways.
Andy?
Yeah, so for us, I mean, workforce, obviously, what we would like to see more of is people with a greater background in computer vision and machine learning and AI. And these fields are still so new that as you go from a computer science major to a math major to somebody else, as you then whittle all the way up to somebody that has experience in machine learning, computer vision, it gets smaller and smaller and smaller. So we would love to see more people jump into these fields. And then from a fundraising perspective, we're both in hardware and we're both in manufacturing. I think a little bit more background or personal experience from investors in those fields would be exciting for me so that we could connect on a deeper level.
And maybe follow on for Annalies, what do you think the state could be doing and the local municipalities to help these guys, hire great Buckeyes for their companies?
Yeah, I think that from a workforce standpoint, the thing that one of the gaps, I guess, if you will, that I see is an access, a pathway into, right? So if you need more folks that have a background in, the visioning component, how are you going to get people there, right? There has to be a very dedicated and concerted effort to say, we recognize that we have a massive workforce gap. We have workforce potential. We have folks that want to be able to get there. But if we don't have pathways forward and the opportunity for folks to even know that that career is a potential possibility, much less how would I possibly navigate to get there, then we're going to continue to have workforce shortages, and we're going to continue to be looking outside and elsewhere to try to fill these gaps, and that is not sustainable.
I agree. I think that pathways point is a good one. When I was growing up, I was told, hey, you got to go to college and go get a good job, which ultimately meant like working in some cubicle farm in an office, right? There was people, and I think our society as a whole have gotten it into their head that working in a factory is somehow beneath you, right? We need to change that as a society, and I think that's something that the government could help with in terms of educating people and shifting perceptions there, because I can tell you the most enjoyable part of my job is actually going into these factories. Like, it is amazing the different types of things that get made there all the time, and it's also critically important that we have a strong manufacturing base, not only for defense, but also to stop this type of supply chain disruption that we've seen with COVID-19. There's now a bigger push for more localization of manufacturing, and I think that resiliency focus is critically important, and we're going to struggle if everyone continues to look down their nose at manufacturing jobs as if they're bad. They're not. They're actually awesome, and there's also a lot of skills that go into being effective in that environment as well, and we need to do a better job of creating those pathways for people.
And I think that if we could bring back some of the work and learn ethos, right, that used to be part of, the way you went into work in our country and others, right?
More of an apprenticeship program.
Absolutely, right? So we have to give you an opportunity to learn, and we have to give you an opportunity to practice, and we have to recognize that, hey, what a better way to do that than actually on the job, because all of that ties directly back to a robust economy.
Yeah, great. Next question.
Mary Schneider, how do we avoid the plateau that is inevitable in any forward progress?
Plateau. Okay, so let me take that question and maybe help us all out here. So for example, you mentioned it. I think a big problem, I remember when I was down with you down at that Honda subassembly plant, and I'm walking through the plant with the plant manager, and I turned to the plant manager, I go, he was very proud. You got 800 people and about 600 robots. And I started looking around. I go, the humans are only there for their vision. They're there for no other reason, because they're picking different parts and they're putting the parts in. They're there for their vision. So I think you mentioned it, Andy, computer vision was a big stumbling block for quite some time. You know, you had these dirty environments, high reflective environments. It was very hard to do. What do you see as, you know, a stumbling block going forward? What are some of the key things we need to get through to go to that 2030 that we just talked about? Andy.
Good question. So I'm going to answer this in maybe like two different ways.
Okay.
So from a technology standpoint, there's certainly a bunch of hurdles that we have to get over as a collective group. So as a human race in general, there's a bunch of still big technical hurdles. Computer vision is one, but really the advancement in machine learning is still that next one. Currently, even some of the best algorithms, they're doing an okay job looking and replicating some of little patterns that humans can do, but we haven't ever taken that next step to be able to start to push on more of global learning, how to replicate a system that can do a lot of different tasks. And so the continual push for me to not plateau is to be continuing funding these programs, continuing to push research and science, and continuing to just not plateau in general as a society. I'm thinking more of education and staying away from fear. So I think fear is a big one that has pushed, again, people to stray away from robotics. And every time someone's pushing back, you're not moving forward. So I think the ability to, as a group and as a culture, just maybe take another forward step in accepting that this is the direction we should be going in, this is going to help people in the long run, is a big one for me. And then continuing to push education. So education for us, and for me personally, I think is very, very important. It's the ability, and it doesn't mean standard education. Mark's invested in a bunch of companies that I think really look to educate in non-standard platforms, but the ability to continuously push education and to give people the ability to education that want to be educated, I think is really, really important for us to never actually kind of hit that plateau and just be able to continue growing and growing and growing.
Okay, next question.
This is one from Lainey Cuthbert on our staff. I've heard caregiving of the elderly will be handled by robots in the future. How will you help that generation accept that transition?
Do you want to take that one, Ben? Or Annalies?
You know, I think it comes down, and I'm hoping you will jump in and save me here in just a moment. I mean, you know, from my perspective, when I sort of think about not just the question, but sort of the causality of it, right? So again, I'm going to go back to the analogy I used earlier. You know, the generation that's in school now, to come 2030, they're going to be doing these amazing things, so they're fearless, right? But the generations that are much, much older, the thing that we are going to need to make sure is in place is the humanity of whatever the technology that we're utilizing as that sort of interface with people. At the end of the day, I think that's, and I would argue that's across the spectrum, old, young, everything in between, right, is where's the humanity component of what we're trying to accomplish and why.
Yeah, I was pausing there because I was actually going to say I don't think robots are going to be heavily involved with constantly caregiving of the elderly, and I don't think it's possible to get them to accept that, primarily because of that human connection. I mean, that sounds like a very depressing future to me, where the only thing you're interacting with is this soulless robot that is, you know, providing you with the necessities to continue existing, but not necessarily enjoying life. And I see having humans involved in that type of caregiving as something that, frankly, is not going to go away.
Yeah, I actually just I look at it very optimistically, in that I feel it's kind of like we're about ready to experience a renaissance. In that we went through the Industrial Revolution, we've gone through the digital revolution, and if you really think of what a lot of knowledge workers do, and of course what a lot of manufacturing people, it's very rote work, okay? And so, I mean, whether I'm sitting in that factory down at Honda taking a part from here and pushing it and putting it over there, I mean, that's not a super fulfilling job. Versus, same thing, I think someone sitting in a cubicle farm, you know, querying this database, throwing a spreadsheet, creating a report for their management on a weekly basis. And so the thing that I look at is it allows people to explain their creativity. And I think Annalies just said it. Just imagine if we had lights out factories for lights out means no people in it. Lights out factories, creating all our essential elements, then allows humans to do things that you have never been able to do before. That's the hopeful future for me.
I think that's an excellent point. Too. I mean, you look at the agricultural revolution of the
Yes.
1800s, right? Like, we went from tons of people in farming, right? Like, if we were 200 years ago, we'd all be worried about if we had grown enough food to last the winter. We don't worry about that anymore. Less than 2% of our population is involved in farming, and it led to this massive wave of innovation and creativity because we were no longer living this hardscrabble existence just trying to get enough food out of the ground. And we're going to see this with automation as well, where it's going to lead to jobs and experiences that we can't yet conceive of because they haven't been created yet.
Yep. Next question.
And ironically, agriculture is one of the biggest uses of automation in robotics.
Yes, absolutely. And thank God for it too, right? So that there wasn't a massive disruption to our food supply chain during this current crisis.
That's right. I think I understand this question. Mike Wenger, what is the biggest risk of robotics not scaling?
So I maybe, I think the question is, how does it become ubiquitous versus a point solution? How's it different been? You mentioned the personal computers. I mean, I remember when there was K-Pro, Atari, Apple, all these different solutions, and it just didn't scale. And then IBM came out and made their IBM PC with Microsoft ubiquitous, and it scaled very, very quickly. So what do we need to do that in the robotics? Ben?
I think standardization drives that next wave of innovation, and we've seen it play out in the PC space with the IBMs and their clones of those PCs, but Windows, right, is that unifying software layer, and we saw it in smartphones as well, when you had iOS and, more importantly, Android come along and basically use software to unify these point solutions and this fragmented hardware space that then enabled new waves of developers to come in and be able to push things out in an outsized way, right? I mean, with PCs and with smartphones, you can have a small team of 4 or 5 people create solutions that have an impact for the entire world. In robotics today, you have to sit there and you have to go brand by brand and create interfaces for each one. There's too much fragmentation, and that's obviously an area we're passionate about already because that's the specific problem that we're looking to solve with our Forge OS platform.
So we're looking for a Bill Gates kind of a solution for robotics.
Yeah, basically a standardizing software
It's
platform.
called a Ben Gibbs solution.
A Ben Gibbs solution. We heard it here first.
Yeah,
at the
exactly.
Metropolitan.
Next question.
Don't you also have to be able to scale the people? I want to push back just a little bit because I appreciate that very, very much and recognize those sort of the where and the how. But at the end of the day, if you can't get not just the users, but the makers and the designers to scale as well,
Yes.
it doesn't make any difference.
So I agree with you there 100%, but I would actually say that these type of platforms help do that because you don't have to now learn 30 different programming languages.
Exactly.
You can
That was
learn 1 or 2, right? And so I think that's an excellent
people
point.
skills,
Yes,
yeah.
absolutely.
Right. Next question. Well, last question.
Last question. Is there a new technology that will be the game changer for the robotics industry?
Andy.
So I think AI is going to be the game changer for a lot of technologies, and specifically, again, that's what our company focuses on. So maybe I'm a little biased, but I think that's going to be one of the bigger game changers in making robots jump over that hurdle and be able to expand and be able to be creative and adaptive and do more things for us.
So what is the big bottleneck in AI, though? I mean, is it processing power? Is it the,
So data collection.
maintenance, management?
Yeah, so and it really goes back down to algorithm. So algorithm is the bottleneck right now because the best algorithms out there are still completely data-driven, and the learning sequence from it, how it works is in its infancy, basically. And so because of it, to learn a simple task that you and I can do, obviously, people need millions upon millions of training iterations to the point where you're solving out the entire problem ahead of time, and it's making small little perturbations around it. And that's really hard to scale. And you want something to be able to learn very quickly, on the fly, with very little data, be able to take big inferences from what it just did, and then reflect it back onto a new piece. And again, why I'm probably a little biased. That's a big focus of what we do at Path.
Great. Well, I think, thank you very much, all three of you. Right now, you'd be getting incredible applause from the hundreds of people in the audience, so we now have virtual applause. But you guys, a great panel, a lot of great insight. And with that, I'll introduce you to Jane Scott, who will close us down.
Well, thank you all. I heard things like think on your feet, curiosity, fearless, problem solving, believe that they can solve the problems of the world. Isn't that an exciting world? I mean, that's pretty awesome, right? Well, thank you all. Next week on Wednesday, we're excited to welcome a good news story to wrap up CMC's program year. We hope you'll join us to hear from our many friends at Can't Stop Columbus. Thanks today for the support of our live stream from the Emergency Response Fund of the Columbus Foundation in partnership with the Columbus Dispatch and PNC, and to all of our online virtual seat patrons. Thanks to all of you. Also, a special thanks Annalies Corbin, Andy Lonsberry, Bill Gibbs, and Mark Kvamme. What a great forum. Thanks to all of you who are watching. We'll look forward to you tuning in next week. In the meantime, be safe and stay well.